Welcome back to the deep dive. Today, we are immersing ourselves in an industry that, can feel kind of ancient, the world of fashion, apparel, and specialized cut-and-sew manufacturing.
Yeah, it's a huge field.
It really is. We're talking about everything from, high fashion garments all the way to military gear and car seats. Basically anything that needs precision fabric cutting and assembly.
Exactly.
And if you're imagining this industry still runs purely on manual craftsmanship with scissors and chalk, you are missing a monumental technological revolution that's happening right now.
That's a great way to put it.
Our sources make it so clear that in today's global manufacturing landscape, speed, precision, and efficiency, they aren't just nice-to-haves anymore. They are the absolute price of entry.
That's absolutely right. And I think the mission for this deep dive is to really dissect the core mechanics of this transformation.
Yeah.
We need to move beyond just the generic idea that digital is faster. We have to understand why these advanced tools, we're talking specifically about CAD systems, automated plotters, and intelligent cutting machines, why they've moved from being a niche competitive advantage to an essential technological mandate for any company that's trying to meet modern scale and demand.
Okay, so we're analyzing a pivotal moment here.
We're focusing on the sheer contrast. We'll look at the inherent limitations of the traditional, manual methods, and then juxtapose those against the operational power that you get from a total digital transformation.
And this shift, it's fundamentally redefining the whole relationship between the initial design and the mass production.
It completely redefines it, from concept to execution.
Okay, so let's unpack this and start at the beginning. Picture the traditional factory floor. What did production look like, say, 20 years ago? And maybe more importantly, where did that process repeatedly fail when it came up against all this global pressure?
Traditionally, the process was a labor marathon. It really was. It involved expert pattern makers literally hand-drawing every single pattern piece on heavy paper.
By hand?
All by hand, using complex curves and rulers. Then came the grading process. So that's adjusting that one pattern for every single size.
Which sounds tedious.
It was incredibly tedious, math-heavy, and all done by hand.
That sounds like a massive bottleneck just waiting for a mistake to happen.
It was. And once the paper patterns were finalized, they were physically arranged or nested on these huge tables covered with layers of fabric. That fabric itself could be 100, maybe more, plies thick.
100 layers.
Oh, yeah. The actual cutting was then done using specialized vertical blade cutters, guided completely by the pattern maker's hand. It was true craftsmanship. But our sources highlight three critical interconnected drawbacks that they just don't work anymore for volume manufacturing.
Okay, let's break those down. I mean, the first one seems obvious, but the scale of the time sink is probably something we underestimate.
It was inherently time-consuming.
Yeah.
And not just in the cutting, but in all the prep work. Creating those master paper patterns, making adjustments, sending them out for approval, then physically laying out hundreds of pieces.
That sounds like days of work.
It could be days or even weeks before the first cut was even made. That lag time completely kills your speed to market in like a fast fashion or a quick response environment.
And I'm thinking, if you have this massive stack of fabric, maybe 150 layers high, and the person guiding the cutter makes one small deviation on, say, the 50th cut,
That error cascades.
it would affect 100 garment pieces below it.
That brings us right to drawback number 2. The extreme vulnerability to human error and inconsistency. If you're cutting hundreds of thousands of components, small deviations, even a millimeter of shift or drag in the fabric layers, they just stack up.
And that leads to waste.
Massive material waste, poor fit across sizes, and high variability in quality control, which is, the absolute opposite of modern lean manufacturing.
And the third major problem, the one that really handcuffs growth, has to be scalability. You mentioned that to increase output, manufacturers used to have to increase labor, space, and time almost proportionally.
Precisely.
Yeah.
It was a purely linear path. Scaling a production was just inherently expensive and slow because you had to go out and source and train more specialized labor, find more floor space for more cutting tables, and manage these huge inventories of paper patterns.
So a 50% increase in output meant...
It meant nearly a 50% increase in all of your overhead inputs.
Yeah.
And that is economically unsustainable in today's highly compressed supply chain models.
But hang on, I have to challenge this point before we move on. We're talking about craftsmanship. Doesn't that manual human touch still have massive value?
It absolutely does, and we have to acknowledge that. Manual work holds an irreplaceable place in certain segments. Think high-end couture, bespoke tailoring, or maybe conceptual product development where a designer needs to physically drape and manipulate a sample.
Okay.
But that manual limitation becomes a systemic liability when the priority shifts to global volume, speed, and most importantly, repeatable quality control. So the technological shift, it's driven by economic necessity, not just, a preference.
That's a crucial distinction. It's about necessity for scale, not disrespect for the craft. Okay, so let's pivot and look at the practical side. For a manufacturer considering a major capital investment, what is the immediate non-negotiable return on investment for adopting digital tools?
Right.
This is where we get into the core benefits. How do these technologies save time and resources, not just marginally, but like fundamentally changing the financial equation?
The benefits are profound. They really are. And you can categorize them into solving three major pain points. The first is just a massive increase in efficiency and a reduction of the product development cycle time.
Okay, so not just cutting faster.
No, it's more than that. Digital tools eliminate entire manual stages. CAD computer-aided design allows designers to create and iterate patterns digitally. This means no more drafting paper patterns, no waiting for physical samples to be shipped back and forth for approval, and no manual grading calculations.
And that takes the timeline from what?
Sources suggest this can take the entire design-to-pattern finalization timeline from weeks down to a matter of hours.
That's astonishing. You're effectively getting rid of the entire physical prototyping stage for the initial design review.
Exactly. And that speed up leads directly into benefit number two.
Yeah.
Unprecedented accuracy and consistency. This is probably the most quantifiable economic benefit. When you contrast automated cutting with manual inconsistency, the differences in waste reduction are just staggering.
Tell me more about that waste reduction. We always hear less waste, but how big is the financial impact, really?
It's huge. In manual nesting, humans are just not that efficient at arranging patterns to maximize fabric use.
Yeah.
Digital nesting software run through the CAD system uses these complex algorithms to optimize the arrangement of every single piece, maximizing material usage down to the last millimeter.
And in terms of savings?
Our sources consistently suggest that for large-scale operations handling costly materials, this optimization can reduce fabric waste, which is often the most expensive component of the garment, by 8% or more.
8%. That's massive.
It's massive. Converting millions in discarded overhead directly into usable product is, the ultimate ROI justification.
That alone completely justifies the capital expense of the hardware. And this accuracy, it translates directly to quality, ensuring the fit and assembly are standardized across all production runs.
That's right. When a digital pattern is finalized in CAD and sent to an automated cutting machine, every single piece, from the first to the 10,000th, is cut precisely the same way. This repeatable precision means less time spent correcting errors on the sewing line, lower return rates due to fit issues, and just overall much higher product quality.
And finally is scalability and cost savings. This gets back to that linear problem of having to hire more people just to increase your output.
This is the big operational shift. By implementing advanced cutting technology, manufacturers decouple growth from labor costs. They can scale production without proportionally increasing their labor overhead for cutting.
And the key here is the machines.
The key here are the sophisticated high-ply cutting systems. These machines allow one operator to supervise the cutting of volumes that would have previously required multiple skilled laborers working for days, dramatically increasing throughput and minimizing reliance on manual skill for the volume execution.
Okay, now that we understand the economic push, let's get a bit technical. We should look at the specific tools that are driving this transformation. It seems like these three technologies, CAD, plotters, and cutters, they form a seamless, integrated workflow.
Right, let's start with the foundation, the CAD system. This software is where the entire digital product lifecycle begins. It's where pattern designers draft, grade for sizing, and manipulate patterns in a completely virtual environment.
And it's more than just drawing, right?
Oh, modern CAD goes far beyond simple 2D drawing. We're talking about tools that allow for 3D pattern simulation, which means a designer can virtually drape the pattern onto an avatar, check the fit, see tension points, all before a single yard of fabric is even cut.
That is truly revolutionary. It means revisions are just a few clicks away instead of a whole day of drafting and cutting.
Precisely. And once that CAD pattern is perfected and nested digitally to maximize the fabric yield, it has to move toward execution. That's where technology, too, the plotters, come in as this crucial bridge.
So the plotter is basically the physical printer for the pattern. It turns the digital file into something tangible. Why are specific high-speed plotters like the Velocity plotters mentioned in our sources so important? I mean, can't any big printer do the job?
Velocity plotters are highlighted for their industrial durability, their reliability, and high-speed performance. They're specifically designed to keep up with the demands of automated cutting tables. They ensure the compatibility between the digital environment and the physical reality of the factory floor.
Excellent. Now we get to the execution phase, the automatic cutting machines. This is where the physical transformation happens and where you get those major volume gains. And it's important we distinguish between the two types of cutters because they serve very different purposes.
Absolutely. First, you have the single-ply cutters. These are not for mass production. They are ideal for extremely specialized tasks, short-run production, handling very delicate or complex materials, or for rapid prototyping where you only need a few samples.
Our sources specifically highlighted the Velocity ProCut X as a kind of benchmark example in this space.
Right.
So what features make a single-ply cutter like that essential for a modern agile operation?
Well, the ProCut X is designed for agility and precision, especially in that prototyping environment. It excels at intricate cuts. Think sharp corners, notches, internal cuts, things that are difficult even for a skilled manual cutter. Its key benefit is that seamless integration with the CAD workflow and minimizing fabric waste, ensuring that even a prototype is cut perfectly the first time.
So it speeds up the sampling phase dramatically.
It does. So the ProCut X handles the precision, the small batches, and the quick proofs. It's sort of like the artist's scalpel.
That's a good way to think of it.
Yeah.
And then you have the industrial workhorse, the high-ply cutters. These systems are built specifically for mass production and are the real engine of volume scalability.
And the big challenge there when you're cutting 100 or 150 layers of fabric has to be friction and fabric drag. I mean, how do you make sure the piece at the very bottom is identical to the piece at the top?
That is the immense technical hurdle. The solution lies in some really advanced engineering. High-ply cutters, often also from companies like Velocity, they employ powerful vacuum hold-down technology. This vacuum basically compacts the fabric layers into a near-solid block.
Ah, so it stabilizes the material.
It stabilizes the material and prevents any shift or drag during the cutting process. They use these specialized, highly accurate, oscillating blades that move at incredibly high speeds, allowing them to cut through these massive stacks with the geometric precision dictated by the CAD file. That combination is what makes scaling operations viable and profitable.
This brings us to the inevitable question, the one that always defines industry disruption. So, what does this all mean for the human element? Does technology entirely replace the highly skilled craftsperson who used to manage that whole manual workflow? Or is there some kind of productive compromise?
That is the most important distinction, I think, for the future of the industry. It is not an either-or scenario, it's a retasking. While technology provides the unmatched consistency and efficiency you need for volume execution, manual craftsmanship remains absolutely essential where the human brain excels.
In conceptual work and artistic execution.
Exactly. We're saying the human element is irreplaceable in areas like genuine couture, conceptual design, material innovation, bespoke tailoring, the areas that really require tactile judgment and pushing creative boundaries.
So the human designer is now freed from the tedious, repetitive tasks that machines handle perfectly.
Yes. The grading, the nesting optimization, the high-volume cutting. The future of the industry is this blend of innovation and tradition, where high-efficiency machines like the Velocity cutting systems handle the execution and consistency, while human creativity is preserved and, frankly, elevated to focus on strategic design, material sourcing, and pushing aesthetic limits.
That's a powerful shift in roles. The craftsperson is no longer just a physical executor. They become a high-level manager of complex systems and a purveyor of strategic design, which, honestly, sounds like a much more fulfilling role.
It should be. The challenge is moving from labor reliance to strategic technology integration. The companies that navigate this shift successfully are the ones who recognize that the machine isn't the competition. It's the ultimate tool for achieving scalability and financial sustainability.
So that brings us to our conclusion. This deep dive really shows that the transformation in apparel and cut-and-sew manufacturing is comprehensive. Embracing these advanced tools, from the CAD software defining the pattern, to the plotters enabling quick transitions, and the cutting-edge automated systems like the Velocity ProCut X. That is the clear path to growth, global competitiveness, and long-term sustainability.
Yeah, that sums it up well.
The traditional methods will, always retain their nostalgic niche, but the industry's trajectory is firmly anchored in digital transformation and smart, efficient manufacturing practices.
This raises an important final thought for everyone listening, regardless of your specific field. If machines can now handle the bulk of execution and consistency, the parts of the job previously constrained by manual error, time, and scale. How does that fundamentally elevate and change the role of the human operator or designer in your own workflow? Does this technological necessity actually free up creative resources that were previously wasted on mundane, repetitive, or strictly technical tasks? That tension between execution efficiency and creative freedom is really the defining challenge and maybe the greatest opportunity of the digital age. Go explore that thought.